Morning, everybody. Yeah, as she said, I am Ian Duncan. I work at a company called Mercury. We're a financial services provider in the United States. We provide banking services primarily for startups and small businesses. We've recently also started to offer personal banking as a product. So if you ever want to start a business in the US, you should definitely use us. We provide a great banking experience. But yeah, I am on the stability team, which is sort of like our version of the SRE process. And so I just want to share with you a little bit today about the techniques, some tools that we've found along our journey for adopting Temporal. As mentioned, we are a Haskell shop, so we had kind of a fun adventure in terms of there was no SDK for that, so we had to build our own, which made the adoption process probably a bit slower than what a lot of you might experience. But nonetheless, we have been using Temporal in production for about over a year now, and we've migrated quite a lot of code over, and we've had nothing but good experiences for the most part. We've had predominantly false starts when it comes to people understanding how Temporal works, but in terms of Temporal itself, it's been rock solid. So we've got a number of product teams here. We've got banking, credit cards, debit cards. We've got multiple mobile apps. We've got risk that we have to do to prevent fraud. And at this point, basically every product team at Mercury is using Temporal in some fashion. Predominantly cron jobs at the moment, but we're also looking to replace our homegrown queue job system with Temporal for the most part. So it's important to say that we are not actually a bank. We don't have a banking license in the United States. So what that means is, in order to provide financial services, we have to partner with a number of financial institutions in the US that have the appropriate accreditation. Some of our partners are good. Other ones are kind of a nightmare to work with. I'm sure if you're in financial tech, you have had the experience of working with partners who have super legacy systems that they've provided some sort of funny wrapper on top of, but they don't really they're not really a tech company. They're just like a bank that has a little thin layer of tech on top, and so they don't do a great job of things. So we have to paper over a lot of those rough edges. And because different banks have different risk profiles, different customers that they're willing to accept, we often have to figure out, based off of a customer profile, do we put them on bank A or bank B? And sometimes when regulatory requirements change, we may have to migrate them over, right? We have to offboard them from one bank onto another. Same thing for credit cards, same thing for wire transfers. We've got partners for all these things. So we've got upwards of 50 partners that we work with. And so despite the fact that we don't really want to be a distributed system, by definition, the way that our business works, we're a component of a distributed system, even though we kind of run our own code as a monolith. So that's kind of where Temporal comes in for us. Previously, prior to introducing Temporal at our company, we built all of these things to try to have a stable system, right? We've got a queuing system that's based off of Postgres. So if you're in a database transaction, you can safely in-queue a job, and if the transaction fails for whatever reason, then the side effects from that queue job don't get performed. Similarly, we've invented idempotency keys, and we've got scheduling mechanisms, retry mechanisms. In the case of retry mechanisms, those tend to be kind of domain specific, right? So for example, our client HTTP code, you have retries for that. If you get a 429, then retry, right? But we didn't have primitives that were designed for more broad usage. And so, yeah, despite having all of this work put into developing stable systems, we would periodically see inconsistencies creep into data. So about, March 2023, our CEO said, hey, we're going to start building a personal banking product. And with this personal banking product, I started kind of screaming on the inside, because I was like, all right, we've got engineers who are having to like fix maybe 50 data inconsistencies a week. We've got a support team that is kind of geared up to support our current business needs. But as soon as like we have 10x growth with a bunch of personal banking customers, we're in trouble. We don't want to 10x our engineering team. We don't want to 10x our customer support team. So like, how can we, get consistency under control, right? How do we position ourselves for that massive growth that we're looking for in the future? And that's roughly when I learned about Temporal. So I pitched my manager on it, spent about 3 months working on a prototype. We started getting the SDK working. And yeah, we had this new shiny thing and we were ready to test it in production, right? But the SDK is in alpha. It's a pretty untested technology. And there was like a lot of organizational resistance of like, we already have all this stuff in-house, right? The previous slide that I showed you, we had a lot of mechanisms for trying to deal with things in a safe way. So we really had to get buy-in, and just pitching people on the idea wasn't sufficient to get buy-in. We had to build trust, we had to introduce it, and like have it battle tested before teams would actually want to adopt it, right? So with that in mind, we developed a number of techniques that I want to share with you today that are pretty pragmatic. I would say a lot of this is not especially novel. These are techniques that you've probably heard of, but it's what's worked for us. It's what's helped us get legacy code to start running in Temporal rather than just writing like greenfield stuff, right? So I think a big part of the trouble that we've had, as well as like explaining the value proposition to teams, like I put it down here, I'm just gonna read it. It's your distributed systems personal time wizard that insists on writing everything down in triplicate, and somehow that like magically fixes your code for you. And people hear this and they're like, you've lost the plot, right? Like you're not a serious engineer if you believe that there's like a silver bullet that can fix all of your problems. And it's true, Temporal can't, but it does solve a lot of pain points. So we had to really prove it to the company, and the best way was to dog food it. Let's see, that's it. So here's some useful techniques we have found along the way. The first thing I want to share, and I think this is a pretty simple one, is when we first started building our Temporal code out, we didn't necessarily know like how we wanted to structure things, where we wanted to put our workflows, or what the naming conventions were that we wanted to have. So we found that we wanted to refactor, move things around several times before we were really happy with like how we had our architecture. And the problem is, right, if you have a running workflow or some activities, like if you just pull them out from under the system and you name the workflows or activities something else, then you can't proceed, you can't make progress with execution. So for our SDK, we added the ability to provide aliases. So when you renamed a workflow, it would also respond to the old name still for the time period that you were using that. And that was like a relatively quick win, so I'm not gonna belabor this too much, but I think if you're using like another SDK where you're using object inheritance, you could probably do something similar with if renaming the workflow and then inheriting to have something that provides the same functionality with like the legacy class name. Another thing that we found to be really critical was feature flagging when we were first rolling out. Our team didn't have like a huge amount of expertise with MTLS, and we were using Temporal Cloud. So it was really critical to us that like when we first got that infrastructure in place, that we felt like we had a good kill switch. Like if we tried to launch it and our workers crashed, that we wouldn't be taking down other parts of the system. Moreover, like we were shipping like Haskell code that's talking to a Rust SDK, and you know, seg faults happen, memory management issues happen when you're testing something like this. So it was doubly important for us that we had the ability to turn this off quickly. Moving beyond like the feature flagging for like the initialization of the app though, we also introduced a lot of toggles between the legacy implementations of like what a workflow would replace and the workflow itself. So because we had not a lot of confidence about like how some of the retry policies would work or timeouts would work, it was really important that we could just cut back over to the thing that we had previously. So this is a diagram here that's roughly outlining how this workflow goes. And I'm sorry that it's a bit small. But basically at the top, we've got where we're initializing the app, and then we choose, do we want to create the temporal workers as well, or do we want to cut over to just using like the legacy worker code? And then similarly, once we actually get an invocation, like run this workflow, well, not the invocation, but when we're using a client to create a workflow, we have to choose if we want to actually create the workflow or run the old code inline instead. Another technique that's been super valuable for us has been the transactional outbox pattern. This is a relatively well-established pattern in the industry. So if you haven't heard of this before, I definitely recommend going and reading about this. But the idea, as I mentioned before, is that we have a Postgres-based job queue as our legacy system. And we don't want to perform side effects if those transactions fail. So like, let's take, for example, user sign up. If a customer signs up and then there's like an application logic error within our database transaction, we don't want to send them an email if we haven't actually persisted the user to the database. So when we started to introduce Temporal, a lot of our product teams were like, hey, this Temporal thing is like not gonna happen inside of our database transactions, right? Like we don't wanna block and wait for a workflow to execute or something like that. And that's true, we don't want that to happen. So what we did is for our legacy queuing system, we introduced the ability to persist like all of the information that we need to start a workflow and put it in our old queue. And then so when the old queue picks up one of those jobs, then it starts the workflow. And so this was a really great way to like smuggle out some of the old queuing stuff and get it over into the new system. One thing I'll say is that workflow IDs are really something that I don't think is talked about enough, or hasn't been talked about at the conference so far. But one thing that's really nice, a nice property of workflow IDs, is that you can only have one running workflow with a given workflow ID at a time, right? So if, for whatever reason, we had an outage with our queuing system, then it was really easy to pick back up, right? We could just try to create the workflow again if it hadn't been created yet. And if it was, then we could just clear it out of the queue. Otherwise, it would actually get created. So this made this transactional outbox pattern super duper easy to adopt for us. And so here's like kind of a state diagram of how we make this set of transitions. So first off, we have a transaction where we're inserting some business data. We're happy with that. We want to commit. And so we queue up the temporal workflow and kick it off, and then we're able to close out the transaction. And we have the confidence that all the information that needs to be there is going to be processed eventually. The downside to this is that unlike with using a temporal client directly, you don't have the ability to wait for the results because you're just like fire and forget with the queued job. But for our purposes, we didn't have that functionality before anyways, so it didn't matter. Another trick that we have developed is something we call golden tests in the Haskell ecosystem. If you've ever used, like, I think Jest for React testing, where it like serializes some HTML and like saves it into a file, this is a very similar concept. The point of golden tests is that we produce like a plain text file of all of our workflow names, the types that they take in, the types that they emit. So in other words, the inputs and outputs. Same for activities. And so if a developer accidentally makes a typo, renames a workflow on accident, or adds an additional argument to a workflow, which we strongly discourage, we could catch that. We could make sure that they hadn't done that and inadvertently broken a workflow in production. So this is practically what this looks like. So these are Haskell type signatures, which is how we output to this golden test file. So you can see in the first example here, we are adding a response value where there was just nothing being returned previously. And then on the second line, we are adding an argument to a workflow that didn't previously have an argument. Both of these have the potential to break stuff in prod, right? And so this is a really, and sometimes we want to let developers make this change if they're really confident that nothing else is using it, or maybe it's like a workflow that's manually fired off. So we don't want to prevent people entirely from making these changes, but what we do want is a backstop to make sure that they're not doing it on accident. So I think if you've got any sort of ability to do like reflection or introspection on your code, other languages can adopt this as well. I don't think this is something that's necessarily specific to Haskell, but yeah. Another thing that we've had really great success with is providing custom interceptors. So if you're not familiar with interceptors, they are a way to hook into certain parts of the workflow or activity lifecycle. So you can modify arguments, you can rewrite like what the payloads are that are coming in or going out, and you can do quite a lot of things with it. So for example, the Temporal engineering team provides OpenTelemetry as an interceptor for most of the languages. And we found a lot of value in writing our own. We do use OpenTelemetry pretty extensively, but we also use things like Bugsnag. You may use Sentry or something else. And we found a lot of value in kind of hooking in and adding extra metadata when we have activity or workflow failures. So similarly, we've got a lot of batch processing jobs that we've been in the process of migrating over. And for those, we found that like a lot of times managing the inputs and outputs of activities are kind of painful. I'm sure if you've written large workflows, you've had the experience of running into like event log size issues. And so we've recently adopted something similar to an open source thing that Datadog provides, which is this large payload codec. The idea is that for payloads, you can, if they exceed something like 100 kilobytes in size, what you can do is you can take the payload, write it to S3, and then just make the argument actually be a reference to that S3 file. So then when your workflow gets, or activity gets an input with that payload, what it can do is it can say, oh, I need to basically like reconstitute this, and it'll go and grab it from S3 and get your 2 megabyte file or whatever. So this is a great way for developers who don't necessarily have the existing mental model about like the limitations of Temporal's event log size to just make their jobs easier. It makes the conversion of existing code where you may be passing around large byte arrays or whatever that much simpler. Another thing we've done that's been pretty useful is this technique called UUID range partitioning. We've got a lot of things that are sort of ETL jobs that run on a particular schedule. We use these for things like reporting information to our partner banks where we generate huge files and upload them to like an FTP server or something like that. So if you've got a database table that's got a primary key that's just incrementing, then it's relatively easy to subdivide parallel execution into like ranges of like do this many things at a time and just do them like evenly distributed. But with UUIDs, you've got randomness and you can't just increment over the range to get an even distribution. So we've written this little algorithm here. I provided it in JavaScript so that way you don't have to read Haskell, but the gist of it is that it subdivides the UUIDs to help you get buckets that are approximately the right size that you want to work with. And so you may not get, when you're fetching this using SQL, you may not get exactly the same size of everything being subdivided, but it's roughly uniformly distributed. So this has been a great technique where we've got something that has to just churn through a lot of data, and right now it's not super parallelized, but we can fan this out using Temporal. So based on our constraints, we can either choose to fan this out using CPU as like a rough proxy. Like in our case, we've got a single large Postgres database, and so we need to manage the CPU usage of that pretty carefully. And this lets us kind of like keep a cap on how much stuff we're processing at a time. So this is kind of roughly what that looks like. We get the count of like how much stuff is in this table that we need to process, and then from there we subdivide it, we fan it out, and this has gotten us some nice speed ups on ETL extraction, and so that's been a big win for some of our teams that have these really long running reporting jobs. So now to get into the thing that I think Haskell has as a really nice benefit that I don't think other languages are necessarily going to be able to do. If you know anything about Haskell, it's a strongly typed language, and it has the ability to constrain the effects that you can perform in a particular context. So for workflows, very specifically, we want to disallow anything that can do I/O, right? We don't want to be able to read from the file system. We don't want to generate random numbers, using system random or something like that. So we introduced this thing called the workflow monad. And here's an example of a workflow in Haskell. You'll see next to echo, it takes x as an input parameter, and then it returns x at the bottom. But the problematic thing is this print in the middle. This is performing a side effect. We don't want to allow that, right? If you try to compile that, you get this lovely compiler error, and it'll say workflow definition can't directly perform I/O, use execute activity instead. So the idea is that we are able to help our engineers. They don't have to necessarily understand the semantics of workflows. We can statically prevent them from accidentally introducing non-determinism. Now, this is just one category of non-determinism, right? This is not, there's a lot of ways that you can still break code by like changing it and deploying it. But we have eliminated a certain category of error. And so that's about all that I have to share today. But I am happy to say that we have open sourced our SDK. And so if you're curious about it, I'm planning on going to the Birds of a Feather area after this. And if you want to learn more or just like ask questions about our experience at Mercury with adopting Temporal, do drop by. I'm happy to chat more. So thanks.
Thank you, and that was really fantastic. That answered one of my questions, which is why Haskell, but there you go. It can check for non-determinism errors. That's really interesting. All right, audience, do you have any questions? We've probably got time for like 3 or 4 questions, actually. So, I see a hand, yes.
Thank you for the talk. That was really useful. You mentioned in your talk how you took great care in maintaining both the legacy system and implementing feature flags and kill switches. For new features, are you doing that natively within Temporal, or are you still using your job queue in Postgres?
Well, yeah, that's a great question. At the moment, we aren't forcing anybody to use Temporal. We'd really rather that they use Temporal because they wanted to. But the area where we have sort of mandated Temporal usage moving forward is cron jobs. We have a legacy, we use systemd timers to run things on particular increments, but that's pretty painful because some of our cron jobs can take 2-3 hours to run if they're data reporting. And so this has been kind of a big sticking point for our infrastructure team for a long time. They want to move to auto-scaling groups, and we can't shut down these boxes while they're running like these 2-hour reporting jobs. So that's the one area where we've just said point blank, like, you're using Temporal. But as far as, using the existing queue job system, I would foresee us using it to a degree for the foreseeable future. I mean, we've got upwards of 1 million lines of code, and it's going to take a pretty concerted effort to fully get off of that system. But yeah, in my ideal world, eventually we would basically have that existing job queue system that has one job, which is to start a temporal workflow. So that way you could just queue stuff up the same way that we do currently, but not have the rest of that implementation overhead.
Other questions? Oh. Sorry, there's probably one over there. Okay, we'll go here first.
Hi, thank you. If I understood correctly, just to clarify one thing, you were talking about utilizing, when you were talking about batch processing, you were talking about utilizing workflow to parallel, to deal with a lot of data.
Yes.
So my question is, am I understanding correctly that you are delegating, instead of using the actual ETL, whatever it is, code, to do the load balance and all that, to Temporal, or did I misunderstand?
Yeah, I mean, that's roughly correct. I think the best way to say it is that when I say ETL, I'm not referring to another tool like Airflow. We've got a lot of stuff that's roughly scripts written in Haskell that pull some stuff from a database, convert it using Haskell, and then send it somewhere. And so the important part is that we're maintaining most of that logic. We're not necessarily converting it into something else, but we're picking out sub-ranges of stuff that we can process instead of just doing it sequentially.
Where was the other one?
Yeah, so thank you for I think you have quite unique insights that I haven't heard in other talks, so thank you very much for that. One question I had a couple of questions around the S3 sort of payload offloading that you do.
Oh, sure.
So the first being, do you enforce that those S3 objects are immutable or in some way, how do you deal with like deterministic and idempotency with those objects?
Well, one thing I'll say is that this is something that we're currently working on. This isn't something that we've fully landed, but the intention would certainly be that they would be immutable. I'm not sure if that helps or not.
Yeah, for I guess follow up. Do you have like an idea of how you're actually going to enforce that, or are you just going to like tell developers to just be careful?
With regards to how it's being written?
Yeah, and how
S3
those
bucket?
objects are then immutable.
I believe you can set that as a policy on an S3 bucket. I could be wrong, but roughly speaking, I would expect that we would have. They're not going to be writing it directly, right? Like we're providing an interceptor or a payload codec that is doing that job for them. So it's not necessarily like a thing that we're gonna have to tell them anything about. We provide that functionality, and as long as they don't do an end run around like the tool to like go read those things directly, then they don't have to think about it.
Sure. Okay. Yeah, that makes a lot of sense. My second question was, are you similarly going to be using like S3 policies to deal with stale object cleanup and things like that?
Yes, definitely. That's a great question. So my thinking on this is that right now we're not using archival to keep old workflows around. We are, once they age out of our retention policy, then they're just gone. So roughly speaking, my intent would be that we would, when they age out of Temporal Cloud, then we just get rid of the objects as well in S3.
Okay, I think I saw some hands over on this side of the room. We have time for one more question.
Thanks for the talk. I was flabbergasted with both transactional outbox and the UUID range partitioning. We're a relatively small team, and these are like two of the first techniques that we reached for when we dealt with similar problems. So that was a pleasant surprise. Question about activity interceptors, and then also just in general with Temporal. To what degree do you have people adopting the Haskell SDK versus are you or is your strategy to provide layers of abstraction on top of that SDK and circulate it amongst your teams?
Yeah, that's a great question. I know that I've seen talks, for example, from Stripe where they've said that they provide like a layer of abstraction on top of Temporal. Personally, I sort of dissent with that approach because what I found is that when people are writing activities, they really need to understand that activities need to be idempotent insofar as you can make them idempotent. And as soon as you start to put like those layers of abstraction on top of it, I think that understanding doesn't really translate, right? So I feel like if you're writing temporal without knowing that you're writing temporal, then you're probably not coming at it with the right mental model of what that code is going to do in production. So I'm kind of personally inclined to like recommend to people that they just go straight to it.
Gotcha. Very quick follow-up. How do you reconcile then your, some of the quality of life with like activity interceptors and abstracting away some of the some parts of temporal with, that philosophy?
Right. Well, I would say there are, as much as I like temporal, I wouldn't say that I feel like it's necessarily like the final form of like what it could be. I think there's still a lot of things that are just incidental complexity. One aspect of that would be like continue as new. Like in my mind, it would be really fantastic if I could just write a function that just recurses and it like does the continue as new under the hood, right? So it's a way to deal with the practical realities of like, there's a category of warts that haven't been solved. So if we can solve warts like with the payload size, yeah, by all means, let's abstract that a little bit and paper over it. But if it's something that's fundamental to the durable execution model, I think, yeah, I don't really want to abstract that out.
Amazing. All right, let's give it up for Ian, please.